Hello, my dear future engineers. How are you all doing? I welcome all of you to our Achievers 2026 batch in which we are going to get prepared for EAPCT JEE examination. I am your Abhi Angel Kennedy sir, or you can call me as A2K sir. Okay, so today what are we going to discuss? Before going to today's lecture, let us recall what we have discussed earlier. We have discussed different types of wave. What are the kinds of wave we have? So generally waves are mechanical wave and non-mechanical wave. And in mechanical wave, we saw there are two types of wave: transverse wave and longitudinal wave. Transverse wave are the wave in which the disturbance is perpendicular to direction of propagation of wave, or the motion of the particle. The motion of the particle is perpendicular, right? Whereas if I talk about longitudinal wave, then the motion of the particle and wave propagation is along the same axis. Please remember this. Okay. So displacement relationship in a progressive wave, how do we write a displacement? If the particle are oscillating in y-axis, amplitude is sine a. So sine of omega t minus kx. This is how we write a wave equation. And if there is initial some phase, we can write it as plus phi. Okay. Then we saw some definition regarding wave. What is wavelength? What is velocity? Right. All other things we saw: frequency, time, period, amplitude, all other things we saw. So velocity of wave is equal to omega by k, or else you can simply write this as, sir, how sir, we don't know how we got omega by k. See, omega is nothing but 2 pi by t and k is 2 pi by lambda. So if I am cancelling it out, what am I getting? So omega by k is equal to wavelength by time period, or wavelength by time period can very well be written as nu lambda. Nu lambda. Any difficulty so far? Okay. So this is velocity of wave. In today's lecture, we are going to study about the velocity of wave motion. The same thing are we going? We are going to relate velocity of particle and velocity of motion. Sir, won't they be moving in the same speed? No. Particle is going up and down. Right? Particle is going up and down. This is the velocity of particle. Wave is going forward. So the time taken for the particle to go up and down is not going to be same as time taken for wave to go from one place to another. Okay, so we are going to in depth discuss about velocity of particle, velocity of wave, and equation of wave. In today's lecture, we are also going to discuss about what? Equation of wave. Okay. So how do I define the speed of wave motion? So let us first find what is the speed of wave. Generally, we write x is equal to a sine of kx minus omega t. If there is some phi, you can add it as phi. Okay, so phi is some phase constant. If I differentiate just this part, this is the part which is representing what? This is the part which is representing what? This is the part which is representing wave. What is this? I'm extremely sorry for my negligence. If the wave is moving in y, then particle should move in perpendicular direction. So either y or z. So if the wave is moving in x-axis, the particle should go in y-axis or z-axis, right? So let me say y. This is speed. This is the term from which we are going to derive what? Speed of the wave. And this is the term from which we will derive speed of the particle. Okay. So let me take this equation alone. And if I differentiate it, with respect to time, k is constant. If I am differentiating x with respect to time, I will getting dx by dt minus omega. If I differentiate t with respect to time, I will be getting dt by dt or 1 plus phi. Phi is a constant. If I differentiate, I will be getting 0. This will get cancelled. If I take this to other side, I will be getting k into, what is dx by dt? X is the distance traveled by the wave, right? X is the direction in which wave is propagating. So this is the dx by dt is representing the speed of wave. Speed of wave, I am using a notation called omega to denote wave, is equal to omega. So velocity of wave or speed of wave can be written as omega by k. So if I see the velocity, it is positive value. Therefore, I can say the particle is moving in forward direction. So as we have already discussed, if one term is plus and another term is minus, particle is moving in forward direction. Sir, what might have happened if I take the equation like y is equal to a sine kx plus omega t. If I take it like this, then in last lecture I have told you that if I am taking both to be positive or both to be negative, then particle is moving in negative axis. So let me show how, sir. If I differentiate this equation kx plus omega t, if I differentiate with respect to time, I will be getting plus omega is equal to 0. Are you able to follow? Dx by dt will become velocity. Differentiation of t will be 1. So velocity of wave is equal to minus omega by k. Velocity of wave is minus omega by k. What does it mean? Velocity is negative. It means particle is going in opposite direction. So even from this one, you can understand why if one is positive, another is negative, it is going in forward direction. Both are positive or both are negative, then it is going in backward direction. Okay. What is this? This is the velocity of wave. The velocity of wave is constant. It doesn't change with time. It doesn't change with time. Now let us talk about velocity of particle. Okay. So it can be omega t minus kx or kx minus omega t, no issue. I am going to differentiate the whole equation with respect to time. If I differentiate this, I will be getting dy by dt is equal to, if I differentiate sine of something, I will be getting cos of something, right? So sine of omega t minus kx, I will get cos of omega t minus kx. And I am going to differentiate with respect to time. So what will happen to this term? I will get omega. Correct? And x is and k and x. What is this x representing over here? X is the position. So position is constant, k is constant. So if I differentiate, I will be getting 0. So this is what is this? Dy by dt. Y is motion of the particle. So if I differentiate motion of the particle, I will be getting velocity of particle is equal to omega a cos of omega t minus kx. Any difficulty? So what will be my maximum velocity of particle? Maximum what is my maximum velocity of particle? Omega times e. Correct. Now if I divide velocity of particle by velocity of wave, what is velocity of particle? Omega a. What is velocity of wave? Velocity of wave is omega by k. So if I cancel it, I get velocity of particle is equal to ak times, right? Ak times velocity of wave. These are few equations, okay? If you are going for examination purpose, then please just remember this, okay? Okay, I have got some important message. Because morning I recorded a video. In that video there was some audio problem, okay? Therefore I have to check, because if I am recording it again and if there is same audio problem, then I have to redo things, okay? Therefore I send a sample to the team and they were checking. So how can we write velocity of wave? Okay, If I am talking about transverse wave, the transverse wave is going, then how do we write the velocity? Always remember that velocity will have a dimension of what? Lt power minus 1 or unit of meter per second. So even if you are getting confused, sir, whether the given formula which I have written is right or not wrong, just do dimensional analysis, because students just confuse whether I have to put density above or density below. Okay. So mechanical wave can be transverse or longitudinal. Transverse wave can travel in solid only, right? And apart from solid, we saw that transverse wave can travel in surface of water also. Whereas longitudinal wave is like sound wave. It can travel in solid, liquid, gas, everywhere it can travel, but not in vacuum. So in the solid, the speed of transverse wave and longitudinal wave are different. In solid, the speed is different. So speed of transverse wave, if I am talking about transverse wave, velocity will be given by root of neta divided by rho. What is neta? Neta is rigidity modulus. And rho is density. So if they are talking about transverse wave, or they are talking about a string, basically it is made up of solid, so it is a transverse wave. If they are talking about transverse wave, then this is the formula. Dimensionally neta, rigidity modulus, or I can tell this rigidity modulus has a dimension of what? Pressure or stress, basically force upon area. So dimensionally this is going to be force upon. So they are all within root. So this m can cancel. If I am taking this above, I will be getting L square t power minus 2 within the root. If I simplify this, I will be getting L t power minus 1. So dimensionally the formula is correct. So always whenever you get confused, use dimensional analysis. Dimensional analysis will help you solving most of the questions. Okay. So just remember this. Okay. You need not worry about that. Velocity in transverse wave is this. The speed of transverse wave is flexible in stretching. So if I am talking about a string which I have stretched, if I am talking about string which I have stretched, so what will happen, sir? So let me take a string, okay, and to one end of the string, if I am hanging some mass, to one end of the string, if I hang some mass, then due to this mass, what will happen to the string? It is going to get stretched, right? So if they are giving in a question about length and tension in the spring, then use this formula. If they are giving rigidity modulus and density, use this formula. Okay. So this is the formula for velocity in string. And mu is mass per unit length. Mass upon length, or mass per unit length. I can very well write this formula as tension divided by mu can be written as mass per length. So this is also the correct formula. So in question what is given, using that you have to calculate. Okay. If they are giving you the tension and mu, then use that to find the answer. Okay. So whatever is given, use that and find. If they are giving you these things, use them. Okay. Neta. Neta is applicable only for solid. Okay. Rigidity modulus is applicable only in solid. Sound of longitudinal wave. If I am talking about longitudinal wave, the speed of longitudinal wave in a medium depends upon the property of medium, such as elasticity and inertia. So the formula is given like this, where B is called bulk modulus. B is bulk modulus, and neta is rigidity modulus. And rho is density. Okay. If I am talking in case of solid, right, in case of solid, in form of long ring or bar, if it is a long rod, not ring, long rod, okay, as I showed in the this one, wire. If there is a long rod, so in wire they will be giving you tension. In long rod they give you Young's modulus. So Y is Young's modulus. So these are all just formula. You have to just remember the formula, and this is density. If I talk about the speed of longitudinal wave in liquid, okay, so in liquid can't have rigidity modulus or Young's modulus. So this will have bulk modulus. Therefore, B is bulk modulus and rho is density. So basically all the formula are simple. They are going to have density in the denominator, and based on the situation, whether it is solid, then we either rigidity modulus or Young's modulus. If it is liquid or gas, then bulk modulus. Okay, so even for gas, it will be bulk modulus. Sir, why sir we are not talking about transverse wave over here? Transverse wave are not formed in liquid and gas. Okay, only on the surface of water we can form that. Okay. So Newton came up with a formula. Okay. About gases, Newton was of the opinion that when longitudinal wave travel in gaseous medium, when they are traveling in gaseous medium, the temperature will be constant. If the temperature is constant, we call that as isothermal process. If the temperature is constant, what do we call? Isothermal process, right? So he gave velocity is equal to root of B by rho, because it is gas. Same formula we have already seen. B by rho, same formula I am just repeating. Just write speed of longitudinal wave is equal to this much, speed of transverse wave is equal to this much. Speed of longitudinal wave in solid, liquid and gas. Everywhere we are going to have some modulus of elasticity divided by density. Remember this. So he came up with a formula V is equal to root of B divided by rho. Okay. Suppose a given mass of ideal gas has a pressure P and volume V under isothermal condition. Isothermal condition means temperature is constant. Okay. So PV is equal to nRT. What are the variable? Pressure and volume are the variable. Right. So if I differentiate P into dV if I am differentiating with respect to volume, what will I get? Plus is equal to 0. So I can very well rewrite this as pressure is equal to minus dP by dV into V. Or should I differentiate with respect to pressure? I think so. Just a minute. What will happen if I differentiate with this with respect to pressure? I am going to differentiate the whole equation with respect to pressure. So dP by dP into V plus dV by dP into P. So I have kept V as it is. I have differentiated this with respect to pressure. Next, what am I doing? I am keeping P as it is and differentiating this. So this is going to be equal to 0. So V is equal to minus dV by dP into P. What will happen to my pressure? Pressure is equal to dP, if I cross multiply, into V divided by dV. If I rearrange this, I can very well write this as minus dP by dV whole divided by V. If you think about this, what is this, sir? Pressure. And what is this, sir? What is this? Volumetric strain. So pressure upon strain can be written as bulk modulus. Correct? Pressure by strain can be written as, volumetric strain can be written as bulk modulus. So this bulk modulus is equal to pressure. Simple, in simple word, that's what they want to infer. If there is a bulk modulus, it can be replaced by pressure. So if I replace that by pressure, what will I get? If I put bulk modulus, instead of bulk modulus, if I put pressure, what will I get? The same formula will become bulk modulus by density will become pressure by density. Okay. But Laplace found that there are some mistakes in this and he gave some correction. The correction is very much simple. Okay, so as long as these parts are concerned, you just need to remember the formula, nothing else. No more concept clarity you need. You just need to remember the formula. Okay, so Laplace correction said that we have assumed the whole process to be isothermal, that is temperature is constant. But what if it is adiabatic process? And what if, so they calculated, okay, they calculate the speed of light in one medium, then they applied this Laplace correction and they found that when they are applying this Laplace correction, the answer was more correct and accurate. In order to apply the Laplace correction, they did nothing but they added a gamma in this. What is this gamma? Gamma is equal to Cp by Cv, that you might have studied in thermodynamics. Okay, for monoatomic gas, diatomic gas, for triatomic gas, right? So this is what is gamma. So gamma can be written as 1 plus 2 by, I'm not wrong, 1 plus 2 by F. This is my gamma. Okay, so till now whatever I have thought, just remember the formulas. Okay, all the things are very much easy. You don't worry about anything, just remember the formula. So if I talk about speed of wave can be given as omega by k. Sir, if speed can be given by omega by k, then why unnecessarily you have given so many formulas? If they are giving equation and asking you to find the speed, you can use this. But if they are giving bulk modulus, rigidity modulus, something like that, what will you do? Then you have to use that formula only. So velocity of particle is equal to, maximum velocity is equal to omega by a, sorry, omega into a, and velocity of wave is omega divided by k. Okay. So if I am talking about transverse wave, then I can use neta by rho, or I can use, if it is a string, I can use Young's modulus by rho. Okay, Young's modulus by rho. If it is a string which has some tension, then I can write this as tension divided by mu, or else I can write that as tension into length divided by mass. Just write all the formulas together. So whatever is given, based on the given quantity, you can find the answer. So speed of transverse wave, I have already given in the previous slide, right? Speed of longitudinal wave. So longitudinal wave, if they are asking about extended solid, okay, because we have said that longitudinal wave have different formula. I have earlier mentioned you that longitudinal wave and transverse wave have different formula. In solid, the speed of transverse wave and longitudinal wave are different, correct? So in transverse wave, we are telling neta divided by rho, but in longitudinal wave, we are having some extra term. We are having some extra term, b plus 4 by 3 times neta divided by rho. Okay, so therefore we can tell that longitudinal wave travels faster, correct? Longitudinal wave will travel faster. In case of solid, Young's modulus by rho. Liquid or gas, b by rho. This b can be rewritten as pressure, so we'll be getting pressure divided by rho. And for Laplace correction, just include this gamma. Okay. Now let us solve few questions. A wave is traveling in positive x-axis. If the wave is traveling in positive x-axis, means one should be positive and another should be negative. This option is wrong. Having a max displacement of 1 meter, so A should be 1, right? So y is equal to A sine of kx minus omega t. If this is my form, A should be 1. So I have found A1, everyone has 1, no problem. Sine of wavelength is equal to 2 pi. So if I know the wavelength is equal to 2 pi, then I can find k is equal to 2 pi by lambda. So 2 pi and lambda is 2 pi. If you are cancelling, k is 1. So if I put value of k is equal to 1, I should get 1x. Which option has 1x? Option A. Frequency is equal to 1 by pi. Frequency is equal to 1 by pi. Omega is equal to 2 pi f. This is my formula. So 2 pi and f is equal to 1 by pi. If I cancel this out, I will be getting. Any difficulty? Any difficulty? Such an easy question. Okay. A wave in a string has an amplitude of 2 centimeter. If I convert this to meter, I will be getting 0.02. So everyone has 0.02. Yes, sir. The wave traveling with the positive x-axis. If it is traveling in positive, it means one term should have positive, another term should have negative sign. Both have positive, both have positive. I can cancel them out. With a speed of 128, right? If they are giving equation, then velocity of wave can be written as omega by k. Sir, are you confused whether it is omega by k or k by omega? Just remember that dimensionally I should have distance by time. K is 2 pi by lambda, so lambda will go up. Omega is 2 pi divided by t. So dimensionally I am correct. So they are telling me that velocity is 128. It means that ratio of omega by k. What is omega? 2000. How do you know that is omega? The term which is in front of t is called omega. The term which is in front of x is called k. So if I divide them both, I should get what? 128. I think both will satisfy because they both are having a ratio of 1:2. If I divide this by this, 2, this by this, 2. So if I am dividing this by this, I will be getting 128, and this by this will also give me 128. Okay. What they have given? It is noted that 5 complete wave fits in 4 meter. 5 complete wave. 1, 2, 3, 4, 5. This 5 complete wave have a distance of 4 meter. So can I tell that what is the distance covered by 5 complete wave? 1 complete wave covers a distance of lambda. So 5 complete wave will cover a distance of 5 lambda. So 5 lambda is equal to 4. So what is my lambda? 4 by 5. So how from this can I find k? K is equal to 2 pi divided by lambda. 2, right? Pi is 3.14. For easy calculation, I am going to write this phi to be 10 by 2. Do you have any issue in that? This 2 is from here and phi has been written. Or in simple word, what I could have done? I need not cancel them. Okay. I need not cancel them. Phi 2s are 10, sir. Phi 2s are 10 divided by 4. If I divide 3 by 4, what will I get? 3 divided by 4 will give 0.75. Are you able to follow? 3 by 4 will give 0.75. So 3 by 4 into 10. So 0.75 into 10 will be 7.5. So I should get my k is equal to 7.5. So something nearby 7.5. This is my correct answer. If you are unable to follow, then let me divide and show it to you. 3.14 divided by 4. 0.87. So if I am multiplying that by 10, I will be getting 7.85. Okay. So based on the question, if they are giving equation and asking you to find the velocity of wave, okay, if they are giving bulk modulus, rigidity modulus, so based on the given thing, you should be able to find the wave described by y is equal to, this is the equation, and what are they asking you? Whether the wave is going in negative direction or positive. Sir, one term is positive, another term is negative. Therefore, I can very well tell that wave is going in positive direction. So the option having negative cancel out each other. What is the frequency and wavelength? So in both of the cases, wavelength is same. Therefore, you need not find the wavelength because they are same. Out of the 4 options, these 2 options are neglected. They are wrong. And the 2 option remaining has same wavelength. So need not find the wavelength. I just need to find the frequency. So this term, this 2 pi is equal to my omega, right? How do you know that's a term which is in front of t is called omega? So 2 pi is equal to omega. What is, from that I need to find frequency, right? 2 pi f. If I simplify, what will I get? F is equal to 1. Sir, how to find wavelength? See, this is k. The term which is in front of it is called k. So k is equal to 10 pi. What is k? 2 pi by lambda is equal to 10 pi. If I cancel them both, I get lambda is equal to 2 by 10, or in other words 0.2. Okay. Any difficulty? Do you have any difficulty? Which of the following statement is true? Both light and sound wave are transverse. No sir, light and sound are not transverse. Sound is longitudinal wave, light is transverse wave. Sound wave in the air are longitudinal, light wave are transverse. This is the correct statement. Velocity of particle at a time t which is at x. So this we have already derived, right? So velocity of particle, they are asking me to find the velocity of particle with respect to time, okay, which is at some position x. So x is constant. So y is equal to a sine of kx minus omega t. So x is constant. So dy, let me write omega t minus kx. So dy by dt is equal to a cos of omega t minus kx. If I differentiate this term, I will be getting an omega. Okay, x is constant, k is constant. This is my velocity of particle and omega a cos omega t. So with respect to time, velocity of particle will vary. Okay, velocity of particle will vary. How sir? See, if this particle is going up and down. Okay, so first as it is going up, at top point the velocity of the particle becomes 0, then it will come down. At the bottom point velocity of particle becomes 0, then it go up. So the velocity of the particle is not the same, it is changing. Are you able to follow? The velocity of particle is changing. Okay. So with respect to time it is changing. If they are asking what is the maximum velocity of particle is omega times a. What is the relationship velocity and slope? So if I take the same thing, okay, if I take the same equation, a sine of kx minus omega t, a sine of kx minus omega t. If I differentiate with respect to time, this differentiation we have already done twice. Okay, so I am not going to repeat this differentiation. What will I get? Velocity of particle is equal to omega a cos of kx minus omega t. Any difficulty? And if I differentiate the same equation with respect to x, if I am differentiating the same equation with respect to x, what will I get? Dy by dx is equal to a sin omega t. Differentiation of sin omega t will be cos omega t, right? So and if I differentiate this term with respect to x, I will be getting a k. Obviously, so if I do this, there should be negative, right? Negative will be over here, negative. Okay. If I divide them both, velocity of particle divided by dy by dx is equal to this term divided by this term, cos and cos cancel, minus omega a cancel, divided by k. What is omega by k? What is omega by k? Omega by k is nothing but velocity of wave into dy by dx, obviously with a negative sign. Sir, what can we find from this? What can we find from this? I can find the direction of velocity of particle. Sir, velocity of particle is going up and down, up and down. So if there is a sine wave, okay, if there is sine wave, this is y axis and this is x axis. And if I ask you what is going to happen to this particle, this particular particle is going up or it is going to go down. If I ask, can you tell? Sir, I don't know how to do that. Simply, velocity of wave, right? Velocity of wave. Wave is going in positive direction. How do we know that? Sir, one is positive, another one is negative. So, wave is going in positive direction, no doubt in that. Okay. So, this term is positive. If I know the slope, how do you know the slope? Dy by dx is the slope of this line. So, this is my slope. Is it positive or negative? Slope is positive. At this point, the slope is 0. After this point, the slope is negative. This point, slope is 0, and this point, the slope is positive. Okay. So, when we are going up, slope is positive. When we are coming down, slope is negative. At the maximum and minimum, slope is 0. Then again going up, slope is positive. So, if you are asking about this particular point, slope is positive, this is positive. So, what will happen to velocity? Velocity will be negative. It means that this particle is going to come down. This particle is going to come down. What about this particle, sir? Slope is negative. Negative into negative will become positive. It means that this particle is going to go up. This particle is going to go up. Let me try to illustrate. Can you see a wave pattern over here? Yeah. Can you see a wave pattern over here? See a wave pattern over here. Let me say this is my average line. So, wave is going up and it is down. So, just see about this particle. What is going to happen to this particle? As per our equation, it is going to go down, right? So, if I rotate, see, is it going down? Yes, sir. Let me bring back to the same condition again. This one. What is going to happen to this particle, sir? This particle. This is going to go up. Can you see it is going up? Right? So, if this was my condition, right? If this was my condition, this is a wave pattern which you can see, I hope. Yeah, can you see this wave pattern? So, if I rotate it, what is going to happen? This is going down, sir. At the same time, what is happening? What is going to happen to this particle? This is going up, sir. If I talk about this particle, this particular particle, okay, this particle, it is having a positive slope. So, what will happen? Down, sir. Did you see? It was initially here, now it is going down. After going down, then it is coming up. Okay. So, using this equation, this particular equation, I can very well tell whether the particle is going in positive direction or negative. Wave is going in positive or negative can be determined by this. Particle can be determined by that. Okay. Wave equation, very much important topic. So, as we all know that a particle is said to undergo simple harmonic motion if it is satisfy this equation. Displacement is proportional to minus x. If my displacement is proportional to minus x, if my displacement is proportional to minus x, then we tell that this is simple harmonic motion. Okay. Do we have any equation for wave also, sir? Yes, we have. For that, I need to differentiate my wave equation. So, if this is my equation, if I differentiate this equation with respect to time, I will get dy by dt, which is going to be, if I differentiate this with time, I will getting this term. A sine, differentiation of sine will give me cos, and omega t differentiation will give omega. If I differentiate the same equation again with respect to time, differentiation of cos will give me minus sine of omega t minus kx, and differentiation of omega t will give me omega. I already have an omega, now I have another omega. So, this is what will be my equation when I differentiate it with respect to time. What will happen if I differentiate the same equation with respect to x. If I differentiate this with respect to x, I will be getting into x. And if I again differentiate this, actually I will be getting minus x. Okay. If I again differentiate it, I will be getting minus from sine, because if I differentiate cos omega t, I will get minus sine omega t. So that minus and this minus will cancel out each other. And if I differentiate the term which is inside, that will give me another actually not minus x, I am sorry. So if I differentiate a is constant, I have kept it is sine omega t minus kx. If I differentiate sine of something, I will be getting cos of something. If it is sine x, I will get cos x. So sine of something will give cos of something. After that, if I differentiate the term which is inside the bracket, I will be getting minus k, because it has minus in it. Okay, therefore minus k. If I again differentiate, I will be getting a as it is. Differentiation of cos of something will give minus sine of something. So that minus and this minus will cancel out each other. Then omega t minus kx. If I differentiate the term which is inside, I will be getting a minus k. Already we have a k, now a minus k. So I will be getting k square. If I divide both the equation, d square y by dt square whole divided by d square y by dx square is equal to minus omega square by minus k square. Remaining all the terms will cancel out each other. Minus will cancel. We know that omega by k is velocity of wave, the whole square. So I can rewrite this formula as okay. Sir, how to verify the given formula is correct or not? How to verify the given formula is correct or not? Use dimensional analysis. Use dimensional analysis. If you are using dimensional analysis, you can verify whether it is correct or not. Sir, how, sir? See, what do we have in left side? Y. Y has a dimension of length. Here t square. Right hand side velocity. Velocity means L t power minus 1. So L by t. As it has square, we are squaring it, sir. Sir, again y, sir. Y will have length and this will be length square. So if I cancel this out, I am getting L by t square, L by t square. So left hand side is equal to right hand side. Simple. So if any equation is obeying this, if any particle is obeying this equation, if any particle is obeying this particular equation, then we call that to be a wave. So this is the equation of wave. Okay. So this is the wave equation. Which one? d square y by dt square is equal to v square. I was just in my brain, I was doing dimension analysis. Okay. d square y by dx square. Okay. A plane wave progresses in positive x-axis. So which is the progressing in positive x-axis? This one, sir. This is the equation of standing wave. Okay. This is negative. About standing wave, we will be discussing in next few lectures. Okay. So this is in positive axis. A wave function, they have given me a wave function. Y is equal to 5 by 4x plus 6t the whole square. Okay. And they are asking me to find the velocity. One method of solving the question is, I should find d square y by dt square. At the same time, what I should find? I should find d square y by dx square. I should double differentiate the equation. If I substitute the value, and I should substitute the value of d square y by dt square and d square y by dx square in this. If I equate, I will be getting v square. Okay. So we don't have enough time. Therefore, I suggest you to take this as homework. Okay. Try to solve this question as homework. you will get the answer. You need to double differentiate the equation. This equation you have to double differentiate. Okay, if you are differentiating this equation twice with respect to time and with respect to x, just substitute it over here. Okay, you can easily find the velocity. But sir, what is the question? They are asking the velocity. Can I find the velocity from omega by k? Yes sir. What is omega? Term which is in front of t is called omega. What is k? Term in front of x. If I solve this, will I get 1.5? Question solved. You please try to solve the question from this method as well. Okay. Use this method also and try to solve. Whether you are getting the same answer or not, let me know. Relationship between phase difference and time difference. Just remember, time taken, okay, time taken for one complete oscillation, okay. So time taken for one complete oscillation. So one complete oscillation means in terms of radian is equal to 2 pi. So it takes to complete 2 pi radian, we need a time of t. So in 1 second, okay, let me rewrite this like, if t time is required to complete 2 pi radian, then the distance covered in 1 second is equal to 2 pi divided by t. Then what is the distance covered in some small t time? It will be 2 pi divided by t into t. Right? What is that distance traveled? Okay, and in some t time. So what is phase difference? How much you have traveled from initial position? Okay. So what is the distance traveled in some small t time? This we write as phi. In small time t, this term 2 pi by t can be written as omega. So phi can be written as omega into t or 2 pi capital T into small t. Similarly, distance traveled is equal to lambda. If I travel lambda distance, then what is my radian? 2 pi. So if I am traveling lambda distance means one complete wavelength. So if it is one complete wave, then what is the radian? 2 pi radian, 360 degrees, right? So for 1 meter, what will happen? It will be 2 pi divided by lambda. And if I talk about some distance x, in x distance it will be 2 pi by lambda into x. And 2 pi by lambda can be written as k. So some small distance x. So phi can be written as k times delta. Sir, which formula should I use? Should I use this formula or this formula? If they are giving you delta x, use this formula. If they are giving you time, use that formula. So delta x is distance. Okay. So based on given only, we are going to make the formula, use the formula. Okay, whatever is given, based on that we are going to solve. The transverse wave traveling along x-axis. Wave is traveling along x-axis. Then the particle should move perpendicular to wave. So particle, if the wave is traveling in x-axis, particle can go in y-axis or particle can go in z-axis. So either y or z. Which of the following equation represent transverse wave traveling along y-axis? Wave is traveling along y-axis. So they haven't mentioned anything. So positive y-axis. See, y-axis. Everyone has y-axis, but see, as both term are positive, it will become negative. Both term are positive, it will become negative. What about this, sir? Wave is traveling along y-axis. Then the particle should travel perpendicular, but the particle is also traveling in y-axis. So this is not an example of transverse wave. It becomes longitudinal wave. So this is my correct answer. If particle is traveling in y-axis, if wave is traveling in y-axis, particle should travel in x-axis or z-axis. Wave is represented by, they have given wave. Okay. The frequency, they are asking me to find the frequency. From this, omega is equal to what? 8. And value of omega can be written as 2 pi f. If you cancel it, frequency is equal to 4 by pi. A wave is represented by the equation. They have given me an equation. Okay. A wave traveling, so in which direction is the wave traveling? Wave is traveling in negative because first term is also positive, second term is positive. So negative, they are giving positive, positive. Then what about the velocity? Sir, how do I find the velocity? One way of finding the velocity is use the wave equation. D square y by dt square is equal to v square times d square y by dx square. Use the equation, solve it completely. Equate both sides, you will get the answer. Or simply you can write velocity is equal to omega by k. We know omega. What is omega, sir? 15 pi. What is k? Sir, 10 pi. Cancel them out. You will be getting 1.5. A wave traveling in the positive x-axis. So see, this is not the correct way, right? Having a displacement on y direction. So everyone is having displacement in y direction as 1 meter. So everyone is having 1. Wavelength is equal to 2. So k is equal to 2 pi by lambda. Lambda is equal to 2 pi. So I will be getting 1. Only this one is correct. Because equation is y is equal to a sin omega t minus kx, or kx minus omega t. So k is equal to 1. What about my omega? Omega is equal to 2 pi f. 2 pi and frequency is equal to 1 by pi. If I cancel them out, I will be getting 2t. I think we have solved the same question earlier, right? A traveling wave in a string is represented by, this is the equation, the phase difference between the 2 points of the particle by force. They are asking me phase difference. So phase difference can be written as omega t or kx. But here they have mentioned me only about the distance. So I am going to use this formula. What is my k? Anything which is in front of x is called k. Pi by 4. And this value is 4 centimeter. So if I cancel them out, I will be getting pi radian. Okay. A steel wire, length of the wire is given, mass of the wire is given, and tension is given. They are asking me to find the speed. So remember, we saw many formula. Which formula is applicable over here? Tension is given, sir. Right? Tension is given. So tension divided by mass into length within root. Tension is what? 60. Mass is pi into 10 power minus 3 into 0.72. If I cancel this out, I will be getting 12, right? And if I simplify this, okay, if I take 10 power minus 3 from denominator to numerator, I will be getting 120 into 72. 20 I have given here, 10 I have given to him. Root of, okay, so before finding root, let me just multiply them both. I am getting an answer of 8640. So answer should be somewhere between 90 to 100. Sir, how do you know that, sir? Because square root of 8100 is going to be 90 and square root of 10,000 is going to be 100. So this value should be somewhere between 91, 92. So if I find something 92, 93, maximum 94, not crossing 94, okay. What is root of 8640? So 92.95, or else I can tell that to be almost equal to 93 meter per second. So based on this answer, you can eliminate other options. They might have given 89. Okay, they might have given 99. You can eliminate those options because we know that answer should be in between them. And what is this value? Is it very much closer to 10,000? No, sir. It is very much closer to 81. So the answer should be closer to 90 rather than 100. Okay. So I have given you just few homework sums in which I have mentioned you, right, wave equation, how to solve the question from wave equation. I think there are 2 questions. Try to solve both of them using wave equation also. I have simply solved them using the formula omega by k. So you should remember omega by k. It is a game changer formula. But also try to solve them with that method. What are the things we covered in today's lecture? We covered to find the velocity. So velocity of particle is equal to omega a cos omega, cos of omega t minus kx, something like this, right? velocity of a particle is equal to negative of slope times velocity of wave. This we saw. Then we saw wave equation. Okay. Then we saw velocity of wave can be given as omega divided by k. Velocity of particle is nothing but displacement of particle with respect to time. Then we saw velocity of transverse wave. Velocity of transverse wave can be given as neta divided by rho if they are giving rigidity modulus. If it is a rod, then Young's modulus divided by rho. If it is a string, then we can give that as tension divided by mu or tension divided by m into L. Okay. Then what we saw? This is the velocity of transverse wave. Then velocity of longitudinal wave in solid. In solid, velocity of longitudinal wave. It was b plus 4 by 3 times neta divided by rho. Just remember all the formulas. Velocity in gas or liquid, beta divided by rho. Then velocity, this beta was replaced by pressure. So pressure divided by rho. Finally, we apply Laplace correction. Then the formula become where this gamma is Cp by Cv. Okay. Or else in terms of degree of freedom, this is the formula. Okay. I hope you might have understand this. If you have any doubt, please do let me know and don't forget to comment. Okay. Also try to give rating to this lecture. Thank you so much. Have a nice day.